Welcome back to another tutorial in quantitative reasoning. So today we're going to cover the concepts of elimination and inspection, which I think are two of the most important concepts in order to be able to answer this section quickly and accurately. So on my right is the timestamps for the video to show you exactly what we're going to be covering in this tutorial. So today we're going to aim to cover three main things. We're going to first go over what elimination is, why we use it, and how we use it. We're then going to go over a particular question type, which is really useful to use elimination in, which is statement questions. And then finally, we're going to end on a slightly wacky QR question that is the can't tell in quantitative reasoning. So before I explain anything about elimination, I want to see what your natural technique is, what your instinct is for solving questions. So we're going to dive straight into the deep end and try a question. So I want you to pause the video now and then give this question a go however you see fit. So now that you've given it a go, we're just going to talk through how I would have done it using the process of elimination. So elimination is fundamentally wanting to score answers out as we go along, to try and eliminate answers as we go in order to do less sums, or in order to fundamentally narrow down to the right answer. So with this one, the first thing that I realised straight away is I've got 5 answer options, but 6 chalky bars. So no, we're going to get rid of one of those immediately. So we can definitely just score out dynamite, as it's not even an answer option. So unfortunately, I don't even care about it for this question. So straight off, we're going to have sort of one less line at the table to worry about. Now, the next thing we're going to do is think about what are the characteristics going to be in order to satisfy what we're looking for on the question. So we're looking for the highest protein per bar. So in order to get that highest protein, we're going to be looking for 2 different factors. We're going to be looking for the highest mass and the highest protein. So let's just look at which ones have the highest mass and protein for these ones. So roughly eyeballing the data, I see that definitely raisin bite is high in mass, as well as chalk bar is the next highest. And then for protein, it's actually the same. It's both chalk bar and raisin bite are the highest. So next thing we're going to do is apply what we call a sense check. Now a sense check is fundamentally comparing one of our current options that we have in good standing to be the winner to the other options to allow us to eliminate it. So we're just going to look at raisin bite in comparison to the other ones, because raisin bite is top of our list here. So looking at the mass and the protein in comparison to the other 3 that we've got is higher in both categories. So we can probably absolutely rule these 3 out. Since both of the factors are higher in raisin bite's more likely to be the answer. So we can rule out the other 3 options. Of course, we're going to keep chalk bar in just now, as it's higher in one and lower in the other. So we're going to have to keep that one in. But let's at least get rid of another 3 options there. So let's get rid of flapjack, gummy bar, and crispy crunch. Grand, this is a much easier table to work with in my eyes. We've only got 2 things to worry about. And in fact, we're just going to do the 2 sums for this one. So we know that 100 gram bar for raisin bite, 100 gram bar has 6 grams of protein. So in order to work out how many is in the actual bar here, we're going to use a little shortcut that we'll learn more about in the proportion tutorial. But for raisin bite here, we're fundamentally going to do 0.7 times 6, which is going to get us to 4.2 grams. So as I said, that's going to be something that we cover more in the proportions tutorial. Using the same sort of logic as 100 grams has, chalk bar, 100 grams has 7.6 of protein. So that means that the 59 gram bar is going to have 0.59 multiplied by 7.6. And I would just stick that one into my calculator if I'm honest, and I would get 4.5 grams out. Awesome, which means the answer for this one is in fact chalk bar. So if you did work out that the answer option is D here, very well done. Take a moment to think about how you went about that, and if you used any of those concepts of elimination that we touched on there. So that question is one that would be a time trap within quantitative reasoning. So it's something that you could absolutely spend lots and lots of time on. So if you sat and calculated every single line of the table, just think about if you would actually be able to do that in the UCAT. The answer is no, you can't allocate 2 minutes to a question like this. So if you are reaching the 40-second mark for a question, this is when we have to start considering, do we invest that little bit more time in order to get the answer? Or do we just move on in order to not impede our performance in the future questions? So keep an eye out for these types of questions, as there will always be shortcuts in order to prevent you spending lots and lots of time on these questions. Now I know that I am absolutely flexing by just drawing all over the screen here, and unfortunately you can't do that in the actual UCAT. Don't get your pen out and draw on the computer screen, please. So you can't just score out lines of the table as I did. You can, however, use your whiteboard for that. So you can use your whiteboard in order to keep track of what you're ruling out and when. And that gives you an idea of what you're eliminating and helps you sort of keep your mind process going. So fundamentally, the concept of elimination is to just get rid of answers whenever we can. At every step, we're just thinking, can we rule any of these out by inspection or by a very simple calculation or by a simple sense check as we did? The reason that we're doing this is basically to give us less work. So as you see with that one, we went down from possibly some candidates doing 6 different calculations, and we actually only did 2. So we narrowed it down to the 2 that is most likely to be, and then chose between those ones. So eliminating options allows us that freedom of doing less calculations and therefore saving time. So statement questions do absolutely come up in quantitative reasoning as well. Now this is where you're given a set of statements and either asked to determine, which is true or false based on all the stuff you've been given. So similar to verbal reasoning, as you remember we discuss in the statement tutorials, we focus on which of the statements are most likely to be true, or which of the statements are going to be easiest for us to work out. And we use the same concept within quantitative reasoning. And it actually links very nicely into the process of elimination that we just learned about. So I want you to pause the video now and have a go of doing this statement question. And again, do it however feels natural. And then we'll sort of look at how we would do it ideally after you're done. So pause the video now and give it a go. So here we've got a couple things to look at. The first thing that is striking me, and I know I would get caught out by it if I didn't pay particular attention to it, is the fact that this is a negative question. We've got which of these is false. So bear that in mind. The correct answer is going to be the one that is false. The rest of them are going to be true. So bear that in mind from the start, and hopefully you'll have noticed that in the question itself. Now, what's our process going to be here? Well, I want to go to the statements that's going to be easiest for me to do. I'm not going to do them in just A to E order, checking if each of them are true or not, because that's not going to be the best use of my time. I'm going to look at which ones are going to be easy for me to calculate and do those ones first. So by a rough inspection of them, options B, option D, and option E all are going to require multi-step calculations comparing basically all the snacks. Yeah, I don't have time for that just now. I'm going to stick with the easy ones, so I'm going to stick with option A and option C to begin with. So option A is a one we can answer simply by inspection, thankfully. So we just compare the 2 rows of the table, and you can see that what option A is saying is actually true. Since we're looking for which one is false, we can rule out option A this time. So coming on to option C, we've got to think here about 3 grams of one thing equaling 1 gram of another. Now again, answering by just inspection, you can see that the Raisin Bite has 6 grams and Crispy Crunch has 2 grams. Not grams, sorry, protein. So it wouldn't make sense for 3 grams of the bigger one to equal 1 grams of the smaller one. Hopefully you can see that logic just doesn't match up with this one. So actually, we can quite confidently say that option C is false, simply based on inspection. I've not done a single calculation here, but I've already found the one that's false. So option C would be the right answer here. But just for fullness and to sort of talk through the other statements as if you tried them and want to know why they are true. So in order to do option B, we'd be looking at which of them has the lowest mass and the highest cost. Dynamite fits both of these categories. So we can see again by inspection that option B is true. Option D here is going to require us to do calculations and compare. But the keen-eyed of you may notice that it's actually just the last question. So in the last question, we compared Raisin Bite and Chalk Bar. We found Chalk Bar was coming up top in number 1, and Raisin Bite was actually in the second position. So based on our previous question, we actually know that option D is true. So again, we would rule that one out. And finally, coming on to option E, there's no simple method to this one. If you were to do it, you would just have to add up all of the 6 numbers here, which is a pain, and we don't want to do that, which is why we'd leave that option to last. If you did happen to add up the numbers, you would find that it does actually equal that 280 grams. So that's talking through why we eliminated each of those statements, and hopefully you can see the key to this question is deciding which statement to start on and being very brutal with your elimination by inspection. So in that one we just saw there, we were able to work tactically, we were able to eliminate, and we were able to get down to the answer by literally just looking at the data, not doing any calculations at all. So that saved us from doing, 5 long, tedious calculations there. So the main thing to remember is if there is any question that is asking you to do long mathematics or multiple equations or just something that you think is too much for 40 seconds, there probably is a shortcut lying in there somewhere. So the key to statement questions are to decide which one to start on and eliminate from there on. And the key to any question where you think that there's just too much work to do is look for shortcuts. There will always be a shortcut there. It just may take a bit of time to find it. So I know can't tell in quantitative reasoning is going to be something that you may be slightly unfamiliar with, but I just want to launch you in the deep end and pause the video now and give this question a go yourself. So this question can initially seem quite overwhelming. You've got a lot of different factors to consider and we're like, oh gosh, how do we consider them all together? So let's look at what we actually know. Ramesh is going to be buying 4 chocolate bars that we assume are the same chocolate bar, and he's got £1 to spend. So quick mental maths, that equates to 25p per chocolate bar. And actually, he can only afford one, unfortunately. He can only afford our chalk bar. So it is actually as simple as that for this one. We can tell which answer option he is going to pick or which candy bar he's going to pick. We have that enough information there in order to accurately answer this question because we only needed to know stuff about the price. So the answer for this one is really as simple as doing that, and it's D, chalk bar. So well done if you managed to get that one, but no worries if not, it was a little sneaky one in there. So when we refer to can't tell within quantitative reasoning, can't tell means there is insufficient evidence available in order to answer the question. Very similar to verbal reasoning when you just don't have the information in the passage in order to answer the question. Now just bear in mind that can't tell is not the same as answering don't know. Don't know would mean you don't know how to work it out. Can't tell means there is insufficient information in order to work it out. So only ever select can't tell if you think you've not got everything you need in order to do that calculation needed. So now that we've reached the end of the lesson, let's just go over what our take-home points are going to be. So hopefully you'll have seen how we work with elimination and you can see how time-saving a strategy it can be. You've become a bit familiarised with statement questions and understand the importance of elimination in answering these questions. And we've seen a little nubbin of can't tell within quantitative reasoning and understood what that means. So in order to consolidate what you've learned in this lesson, my main tip is don't be scared of using inspection. So when you're practicing questions from now on, edge on the side of using inspection and elimination, and I promise you it will end up saving time. Well done on finishing this lesson, and I'll see you again for another one soon. So if you like this video, give it a thumbs up, leave a comment below, and share it with your friends so that they don't miss anything out on the journey into medical school. To unlock the rest of the series, which is 70 videos including live walkthroughs and over 1,000 different questions, just click the link in the description below.